Hello, my name is Kyle Hutson, and I am one of the system administrators for Beocat. Beocat is what we've named our supercomputer here on the K-State campus. So I'm going to tell you what makes a computer a supercomputer. A lot of times when I ask what makes a computer a supercomputer, people come up with things like it's really smart or it has lots of programming. Well, actually, they run the same programs as other computers, so there's not a lot of difference there. What makes a computer smart really is how fast it is. So that's one of the things we look at is how fast a computer is. And the other thing it has to be is big. By the time computers get to be big enough that you can fit them in a whole room instead of just under your desk or something like that, that's when we start getting into the supercomputer kind of range. So I want to tell you a story. Back in 1985, they built the world's fastest supercomputer. It was called the Cray 2. It cost tens of millions of dollars. It took a team of engineers about 2 years to put it together, and it was the fastest thing around by so much. It was crazy. I found out about it. I was a middle schooler. I found out about it because it was on the evening news. That was kind of the internet headlines of the day. You had to watch the news on TV in the evenings. And that's how I found out about it, because it was like just this big headline, the world's fastest supercomputer. And it was so much faster than anything else out there. It was just crazy. But I have something even faster than that now. Yeah, it's my phone. As a matter of fact, that Cray 2 has about the same amount of processing power as an iPhone 3. How's that for being fast? So, the question becomes then, is that computer still a supercomputer? Is that Cray 2 still a supercomputer? Remember, at one point, it was the fastest one in the entire world. But we said that a supercomputer is one of the biggest, fastest computers that's around right now. So it is still big, but it's no longer fast, because if your phone's faster than it, then it's obviously not very fast. So the amount of processing power that we have in Beocat, in another 10 or 15 years, we'll be able to fit it under your desk as some sort of good server class kind of computers. And in another 10, 15 years after that, you'll be able to fit it in your pocket as a phone or whatever brain computer interface thing that we haven't even thought of yet. And I say that because I can tell you that back in 1985, nobody was thinking about carrying around a phone in their pocket. Phones were things that were stuck to walls with cords. Why would the thought of even carrying a phone around in your pocket seemed absolutely ridiculous. Whatever thing we come up with in the future, the new technologies allow us to do new things. And that's because computers keep getting smaller and they keep getting faster. So we can keep fitting more and more in your pocket in the form of a phone now, usually, as you would be able to a few years ago, just at a desktop computer of some. I told you that back in 1985, they built that one big computer. Well, now we don't do that. We don't take and build one big computer. We take a whole bunch of smaller computers and they hook them together to act like one big computer. I'm going to show on the screen here one of the computers that came out of Beocat. It has the same things any normal computer has. It has a power supply, CPUs, memory, fans, hard drives. All those things are things we'd find in any normal computer. Here's the differences. The first you can't tell just by looking at it. That is the CPU. In order to be part of a supercomputer, we have to use some of the fastest CPUs available. Now, by the time computers are a few years old, we can't use them as part of a supercomputer anymore. The other difference is this piece over here. This is our high-speed networking. These allow these computers to talk to each other very, very fast. This card right here talks to each other at least 40 gigabits per second. That's about 1,000 times faster than the fastest internet you can get in Manhattan right now. And if you've heard of Google Fiber being the fastest internet you can get in the whole United States, it's about 50 times faster than that even. We did some calculations to figure out how fast that was. You could take an entire Blu-ray disc, completely full, all the special features, full 3D, everything, and you could transfer it from one computer to another in about 10 seconds. And that's our slow ones. Our fast ones can do it in less than 5 seconds, about 3.5 seconds, somewhere in that range. So they can talk to each other very, very fast. So between this high-speed networking and some special software, we can hook these together so they act like they're one big computer instead of a whole bunch of smaller computers. The last thing you'll notice different is the size and shape of it. We call this a pizza box because it's about the size and shape of the pizza box. And it's not just us that calls it that. we were to call Dell, Lenovo, HP, any of those computer guys, we'd say, give us a pizza box server, and they'd know exactly what you're talking about. We use pizza boxes for two reasons. The first is what we call density. Density is a measure of how tight we can squish things together. Think about how big your class is, and if you go to a computer lab in your school, you probably got, 25, 30 people in that computer lab? Well, these, because they fit together one on top of the other, we can fit up to 47 in just one rack. So about 1.5 times as many in one rack as we had in your whole computer lab. And as we said, each one is more powerful than a regular desktop anyway. So we can fit up to 47 in one rack, and we have almost 450 in a single row of Beocat, and we have multiple rows. We can fit thousands of computers in here if we needed to. And that creates another problem for us. When you're using a laptop and you put it on your lap, you know it gets hot? That's because the heat that comes off the CPU, the more work a computer does, more electricity gets turned into heat, and it gets hot on your lap. And that causes us to have a real heating problem. So we have to run the air conditioner in here all the time. If I was taking you on an actual tour, you'd notice that you were standing right underneath some air conditioning vents. These pizza boxes are all built the same way. They suck the cold air in the front and they spit the hot air out the back. I can't really show you how hot or cold it gets because I'm not there with you, but we have the thermometer on the wall that can tell us the different temperatures as the air is coming in and out. So in a distance of about 3 feet, you can say the average temperature in the front is about 68 degrees, and on the back, it averages over 85 degrees. So it's a lot of difference. As a matter of fact, the place where I open up the back of the cabinet back there, it goes even more than that. So the reason it gets hot is because in a normal desktop or laptop, you have inside each CPU, there's one or more cores. It used to be that almost every computer had just one core, but now almost all of them have at least two. So a normal desktop right now will have either 2 or 4 cores in it. Some big gaming systems might have 8 or even 16. That's not usual. We have some machines here that have 128 in a single one of these computer boxes. And we have about 9,000 cores in all of Beocat. So that'd be like sticking about 4,000 laptops in one room. So if you had 4,000 laptops in one room, you know how hot that would get. You can think about that, right? But also think about how much work you could get done if you had all those computers working on the same problem at the same time, which is what a supercomputer is meant to do. So that's one measure we have of how big a supercomputer is. It's how many cores it has. And we have about 9,000 in Beocat.
We did have I think it was somebody in veterinary medicine who said their stuff was going to take too long and they wanted to see about running it on Beocat. And typically when somebody says something's running too long, by the pain threshold there tends to be about a week. If something's going to take longer than a week on their laptop, they say, what's a better option? So I said, okay, well, how long is it taking? Well, with what it's done so far and what we're going, I think it's going to take about 153 years. Yes, that's way too long. So we actually got a couple of students that went to work on that, and we had the entire thing done in less than 2 weeks.
Another thing we look at is how much memory or RAM a supercomputer has. Now, RAM is a measure of how many things you can do at once. So if you have like a YouTube video playing in the background while you're typing up a document, or if you're like me and have lots and lots of tabs open, you know how when you get too many tabs open, how your computer slows down? That's because you don't have enough RAM. Well, a normal desktop right now will usually have about 8 gigabytes of memory or RAM. A bigger gaming system might have 16, or some even big ones now even have 32, but most of them have about 8. That's a pretty normal number. We have some machines here that have over 1,500, and in all of Beocat, we have over 40,000 gigabytes of memory. The last thing we look at is how much storage a supercomputer has. Now, a backup drive that'll save all your documents, all your pictures, even all your videos, those take up a lot of space. Those have a capacity right now of about 1 terabyte. We have over 3,500 terabytes. So you take all your normal desktop or laptop things, we blow it up to ridiculously huge proportions, and that's what makes it a supercomputer. At this point, if you were on a live tour, I would be asking for questions. But since you're not here in front of me right now, I can only think of some of the questions that I've gotten asked the most often, and I'll answer those. So one question that I get frequently is, can you play games on it? And the answer is not what you're thinking of as a game. I mean, we can play games as far as like logic games and that kind of thing, but there's no monitors on it. There's no keyboards. Everything here is accessed over the internet. So it has a lot of computing horsepower, plenty enough to play lots of games. As a matter of fact, some of these machines even have game cards that make a really, really nice gaming system if you wanted to use it for that. But there's no monitors hooked up to it. And actually, if you hooked up a monitor to one of these computers, you'd just see like a plain blank line of text. It doesn't look exciting at all because we're using all this computer power for the computation, not for making pretty graphics. Next question. Why do you have to run the air conditioning when it's cold outside? Well, it puts out so much heat that even when it's cold outside, we still have to pull in air conditioning. Just pulling in air isn't enough. I'm going to tell you a story about back in December of 2016. We had an air conditioning outage going. This is in December, and it was at 10 o'clock at night, so it was about 20 degrees outside at night, so really cold. And we have two systems that work together. The first is a monitoring system. That's what you see with that picture up on the thermometer up on the wall. And the other is a notification system. So when things go wonky, I actually get a text message that tells me I need to get things fixed. Well, we didn't know it, but our notification system was broken. So when things got too hot, we didn't have any way of knowing about it. This happened about 10 o'clock at night, and between 10 o'clock and midnight, so about 2 hours, it went from 65 degrees in here, a little chillier than it showed on the thermometer there, up to 115 degrees in this room. So it gets really hot really fast when we don't have any air conditioning. As a matter of fact, between the computers and the air conditioning to keep it cold, we spend about $100,000 worth of electricity in this room every year. Next question, what happens when the power goes out? Well, we actually have two systems for that. We have a battery backup system that'll run this whole thing for about 10 minutes. If it goes longer than that, we have a generator outside that kicks up and starts putting out power, but that generator isn't big enough to run the whole room. So we have certain systems that are essential that we don't want to go down at all. Those are the ones that are hooked to the generator. These that are part of Beocat, the computing part of it, those just go away, they die. And we bring them back up and they have to start their jobs back over again. So what do the orange lights mean? I've had people notice the orange lights on the front of machines. That means there's actually something wrong with that particular server. And the nice thing about doing it the way we do now, instead of the way they did it back in the Cray 2 days, I was talking about that, where we built one big computer, is that when a part of it goes down and doesn't work right, we can just say, don't use that part right now. And it kind of becomes convenient. I can work on that as I want to. Sometimes the problems aren't a big deal. Some of these orange lights have been on for a long time, and they're just going to stay that way because they're not worth fixing. And the computers still run. Other times, that just means that we can't use that until we get that particular server done. And the last question, and probably my favorite, is what is this used for? This is used for scientific research. This is doing heavy-duty number crunching stuff all the time. The biggest things we do on here are genome analysis.
One of the things Kansas State is known for is as being an agricultural college. So here's your useless trivia for the day, is that the wheat genome is actually several times more complicated than the human genome. We do a lot of genome analysis on Beocat, and that is actually much more involved computing-wise than doing human genomics, because the wheat genome is so much more complicated. The biggest uses we have of Beocat are genomics, wheat genomics in particular, chemistry, molecular modeling, that type of thing, and artificial intelligence and machine learning. That's something that's fairly new within the last 3 years or so. It used to be that we had everything set up for artificial intelligence and machine learning, and nobody ever used it. And then about 3 years ago, TensorFlow came out. I'm sure you're going to learn about TensorFlow, as that's one of the most common machine learning programs out there. once that came out and it became an easy way to use it, our systems that use that have been used nonstop. We use those. We also do use some analysis of photograph data, which can be really useful because, for instance, there will never be another spring 2022. You can take and see what your crops look like in spring 2022 and then correlate that with how much moisture we got on which dates, how much sun we got on which dates, and correlate that with how broad your leaves are or how much grain is produced out of a crop. That gives us some insight that we wouldn't ever be able to have and we can't replicate any other way.
So it's not used by the web server or for payroll or anything like that. It's used for heavy-duty number crunching research all the time.
However, computer science is used everywhere. We deal with people from all sorts of professions, all around, everything from medical to agricultural to specialized academia. We have people going into stock analysis. We have people going into language arts analysis, linguistics, political science, something you wouldn't think of, how people vote in certain areas for certain ways, Department of Business, statistics, all sorts of these things are all used on the high performance computing cluster. Computer science really is mostly software. We do have computer engineering, which is more the hardware side of things, and that's what my degree is actually is in computer engineering rather than computer science. Both have their place. Matter of fact, with computer engineering, I was always the software when I was with the hardcore hardware guys, and I was always the hardware guy when I was with the hardcore software guys. So it's kind of a nice mixture between the two. Computer science really is focusing on the software. Now, that software can be everything from like networking and some low-level types of things like that, up to machine learning, up to some algorithm that makes things work. We have several graduates here and even undergraduates that are working on systems for other labs. So they might be embedded in the biology department and they will help them with their algorithms trying to optimize what they're working on so that they can run through their stuff faster. The world needs scientists. And technology is a great place to go with that. I won't tell you that is the only place to go. There are lots of areas, but the world needs lots of scientists. And it's something that can't be replaced. It's something that can't be replicated. And it's just a great field to get into no matter which way you take it.